Hi, 7th grade. All right, we are on lesson 4, session 3, recognizing graphs of proportional relationships. All right, we got two different things going on. We have the cost and we have the time. We've got company A, company B. Let's go read the question. Josephine uses a graph to compare the cost of renting a car at two different companies. Is the relationship between cost and time proportional at either company, and how do you know? Okay, so if it is proportional, it'll go up at a constant rate. We know that we want to go look for a slope. Let's just focus on company A, so blue line only, okay? Do I have some nice crosshairs? Yes, I do. Let's go find the slope. So if I start here, let's look at the rate over here. This is not going up 1. This would be going up half of 8. What's half of 8? 4. So this is 4. This is 8. This would be 8, 9, 10, 11, 12, 16, 17, 18, 19, 20. Okay, now that I got some numbers put in there, that helps. And then this is not going over 1. This would be going over a half. And then 1.5. And then 2.5. Okay, now that I got those filled in, it makes it a little easier to find my slope. The slope is up 4 over a half. Up 4 over a half. So down here, I'm going to say company B slope, or the constant of proportionality, is up 4 over half. Okay? And it looks like it's going to be that way the whole way. Do you guys agree? It doesn't stray from that ever, and that means it is constant. So already I know company A is constant. It's not going to just all of a sudden be like, oh, but once you have the car for 4 hours, now we're going to make you have to pay like $50, right? It's constant. Now let's go look at B. B is a little different. B starts at 8. It doesn't start at 0. So let's go find the crosshairs. Here's another crosshair. They share this crosshair. Here's another crosshair. Here's another crosshair. Okay, let's go find this slope. This slope goes up 4 over 1. Oops. Up 4 over 1. I see a small spot that I made a mistake. This should be company A. Okay. Now, is that constant for company B? Can I go up 4 over 1, up 4 over 1, up 4 over 1 each time? Basically, what your stairs to look constant. Like, they shouldn't all of a sudden jump up, boom, 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 right? It wouldn't make sense for the line now to skyrocket that way, okay? If it's constant, it'll just stay with the same. Yep, it looks like they're both constant. So, is the relationship between cost and time proportional at either company? Yes. How do you know? Because I could find the slope of each of these, and each of our dots landed on the slope. Okay? Let's go answer some questions. It looks like you could make a graph. Now, the charts that they made down here, these tables, they took the time, which is our x-axis, and they took the cost, which is our y, and they made little charts of x comma y. So at 0, 0, you can make these into an ordered pair, right? You could make these all an ordered pair, and they would land on that line. 0, 0, 1, 8, 2, 16. Do you see that? And then for company B, they did the same thing. This is still your x's, and this is still your y's, and they just basically made them into an ordered pair, into coordinates, okay? Once you have your coordinates, can you now find the slope by taking y divided by x and see if you can get the same answer every time? Let's test that out. What is 0 divided by 0? 0. What's 8 divided by 1? 8. What's 16 divided by 2? 8. So besides 0, 0, that one doesn't matter. Do I have a constant proportionality? Yeah. So if my next one said 3, I know what the next thing should be because I could multiply it by 8, right? So 8 times 3 is 24. What if the next one was 4? I could take 4 times 8 and get 32. So I can keep finding each of my points, right? How about company B? Is it constant? Let's see. If it is, I can take the y divided by, so what's 8 divided by 0? Well, 0. Let's see. Sorry. 8 divided by 0 is undefined. Okay? You can't, like, get an answer for that. But what about 12 divided by 1? 12. What about 16 divided by 2? Ooh, this one's a little tricky. Why are we not getting a nice, beautiful constant? Let's see. We said it was up and over. Up 4? No, 8 plus 4. 8, 9, 10, 11, 12. So it's up. So this was up 4. And then over 1. Oh, so we should be able to multiply it 4 over 1. We should be able to get 4 over 1 for each of these, right? It's a little tricky. Company B is a little messed up. Huh, that's interesting. Does that mean it's not a constant proportion? Did we make a mistake over here? Company A, you can divide each of your x's and y's and get a nice answer, right? But company B, you cannot divide your y's and your x's and get a nice answer. So that means, oh, I made a mistake here. That means A is constant. B is not. And how we should have known that is we should have taken our x's and our y's and divide and divide and divide. The big reason why it's not constant is because it started at 8. It doesn't make sense, right? If you take the car out for 0 hours, you shouldn't have to all of a sudden pay $8, right? If you haven't taken the car out, you haven't taken the car out and you shouldn't have to pay for anything. Okay, so that makes sense. A is constant, B is not. And then here's a way to prove it. I can divide all of these company A ones and get 8. If I divide these, I get all sorts of crazy numbers. 8 divided by 0 is 0. 12 divided by 1 is 12. 16 divided by 2 is 8. I mean, there is nothing constant about this, right? Okay, so A has a line go straight through, and it goes through the origin. B does not have has a straight line, but it does not go through the origin. And that's where we made a mistake. So because that pink line doesn't go through the 0, 0, I know it can't be constant because that doesn't make any sense, right? I can't say that I didn't take the car out and I still have to pay $8. That'd be ridiculous. Okay. Now we get to go answer questions. We'll go through these quickly. Don't worry. So is the relationship between cost and time proportional at either company? Yes, only A. You can take y divided by x and get 8 each time. So 8 is our constant of proportionality. Ooh, getting close. Okay. How are the graphs representing company A and company B alike and different? Well, the company's graphs are still straight, right? The lines are still straight. However, company B, the cost of a constant dollar multiplies differently. So company A, the number of hours can be multiplied by the cost at each time, but for B, you cannot do that because it starts at 8, right? So how are the graphs A and B alike and different? They both are straight lines, but both companies start their 0 hours differently. What that means is company A, it's 0, 0, 0 hours is $0, but company B was 0, 8, 0 hours, $8. It just doesn't make sense. The graph for company B does not pass through the origin. Why does that show the relationship between time and cost is not proportional? Because it wouldn't make sense to rent a car for 0 hours but have to pay $8. It just doesn't make sense, does it? Number 4, the graph at the right shows a relationship between cost and time at company C. How are the graphs for A and C alike and different? Okay, so C is not a straight line. Does C go through the origin though? I mean, yeah, C and A both start at the origin. Oops. Is the relationship between time and cost proportional at company C? You guys, if the line is not straight, it's not going to be proportional. You don't even have to go find anything else. No. The graph of the proportional relationship will always be a straight line that passes through the origin? Yes. If it's not a straight line and it doesn't go through the origin, then not all of the points of the line are going to be equivalent ratios, right? So for it to be a proportional relationship, it has to go through the origin and it has to be a straight line. Number 7, think about all the models and strategies. Okay, we're going to skip that because I don't think that we need to worry about this. I think we need the graph and we need the table and we need our y equals mx plus b formula. I believe all 3 are super important. So that's why we're skipping number 7. Number 8. 6 people ride a bus to go to work. The table shows their travel time and distance. Make the graph to represent the situation. Okay, so let's make, should we have x be our time? And then y can be the distance. Okay, in miles, and this is time in minutes. Okay, let's see, what kind of scale do we want to use? Looks like we got a 4, a 12, a 16, and it has to go all the way up to 32. Woof. Let's do our time go by, if I go by 2s, what would it be? 2, 4, 6, 8, 10, it won't be big enough. So how about we go by 4s? I mean, I guess that would work. I don't really like it, but we could. We could say this is 4, and then this would be 8, and then this would be 12, this would be 16, and then this would be 20, and then this would be 24, and then 4 times 7 is 40, oops, 7 times 4 is 28, and then 8 times 4 is 32, and then 9 times 4 is 36. Okay, good enough. Now my distance goes, by halves. Okay, we're definitely going by halves. So this would be 0.5, 1. 1.5, 2. 2.5, how many? We have to go all the way up to 3.5? Okay. 3. 3.5, 4. Okay, now that we got our scales, we can go plot some points. Let's do the first one. Remember, this is our x's and this is our y's. 12, 1.5. So go to 12 and then go to 1.5. So here's our first dot. And then 2, 16. So we'll go to 16, go up 2. Then the next one is 26, 30. Go to 26, so it's going to be in between here. And then go to 3, right here. 2.5, 20. So we'll go to 20 and go to 2.5. Okay, and then we've got 4 and 0.5. So go to 4 and go up 0.5. And then we got 3.5 and then 32. So go to 32, go all the way up to 3.5. Okay. Is there a proportional relationship between the number of minutes and the number of miles? Explain using your graph. Now, if I were to graph this line, it would look like something like this. Now, I know I don't have a straight edge, but you can tell, right? That's not a straight line. If it were a straight line, wouldn't this dot go over here, and then this dot would go over here? Because it doesn't look like the slope is going like this, and all of a sudden, it doesn't. The slope is definitely wrong, okay? So even without dividing my y's and x's to find a constant of proportionality, I can already tell. Is this slope constant? No. The line isn't straight. Okay, number 9. How can you describe the relationship between x and y that each line represents? Okay, so let's look at A and B. Does line A represent a proportional relationship and line B represent a non-proportional relationship? Well, look at them. Are they both straight? Yes. Do they both start at 0? Yes. Okay, so we like them, right? So I don't like A. A is a bad answer. How about B? Line A is a proportional relationship and line B is a non-proportional relationship? No. Hold up. Did this just literally ask the same question? What the heck? That is silly. Okay, C. Lines A and B are both represented as proportional relationships? Yes. And D says lines A and B are non-proportional. Guys, I don't even need to go find my slope. And I know they're proportional because 1, they are straight lines, and then 2, they go through the origin. Okay, so C is correct. 10. Naomi says the graph represents a proportional relationship because it's a straight line. Is Naomi's reasoning correct? Well, we know how being a straight line is only half the problem, right? No. It should go through the origin. It needs to be a straight line and go through the origin. All right, guys, 75 and 76 we'll do in class. Please go ahead and scan 74. Before you go, let me give you today's, big old master idea that I want you guys to get out of this lesson. Here's today's big idea. For a line to be a proportional relationship, it has to be a straight line and it has to go through the origin. Okay, that's what the big idea for this lesson is. For it to be a proportional relationship, it has to be a straight line and it has to go through the origin. All right, guys, see you later.